Hi, guys. This is Miss Baker, and this is the third time I've recorded this. Hopefully, this will work this time. Okay, we are going to compare and contrast work and power. So, if I say something like, man, I worked for 4 hours last night grading papers, I worked so hard. If we're thinking about physics, would you define what I did as work? Now, the physics definition of work is you have to make something move. Now, you could technically say that I was making the keys move. So I was working the keyboard, but I wasn't making anything else move. So therefore, based on physics, I wasn't working. Okay. So what I want you to do, I've got a little video that I want you to watch, and I'm actually going to speed it along a little bit. But, well, no, I'm not. I want you to think about at what points are the actors doing physical work? When are they moving things? That is considered work.
Lexi's Sweet 16 cake is going to be very personalized. This cake is going to tell a story about her. The bottom tier is going to be more beach. You know, I'm thinking the bottom should be very beachy with sand, and that'll be the California tier.
You can put the ball up here on the corner.
The next tier, I'm going to go into a cityscape. Like, that's okay. I like there's different variations in height. And then as we go up the cake, is going to be like contemporary fun gift box with some stripes, polka dots, and a bow. This cake is literally going to scream Lexi. I mean, I'm going to have it in like bright neon sign. Done. Cousin Anthony, get your ass upstairs. Come on, you got to go. What's your door? I got it. You think it's heavy, man. All right, no problem. Dang. What happened? You let go? You got the board, but not the cake.
What the hell happened?
Okay, so when Anthony and his buddy were taking the cake from the cake decorating room and getting it ready to go down the stairs, they were doing work on it. When they put it on the stairwell or the stair rail, they stopped doing work on it. They had, when you're doing work on things, you're transferring energy from one place to the other. In those terms, they utilize their energy in their bodies to transfer and move this object. When the cake was put on the stair rail, I can't say that today, the object was stopped. And then when it got unbalanced, it fell. As it fell, it was having work done on it, except for in these terms, the work was gravity. Okay. So we are going to watch another video that explains this.
Eureka! The story so far. Mass refers to how much stuff a thing contains. Weight refers to the rate at which that amount of stuff is being accelerated towards the Earth. In other words, weight is just another way of saying force of gravity. An object's mass never varies, but its weight can go up or down depending on the force of gravity acting on it in various parts of the universe. And now, work. These barbells have a mass of 120 kilograms. Since they are resting on the surface of the planet Earth, We know that the force of gravity acting on them is about 10 times that number of newtons. It takes a very strong man to lift something that weighs so much. Because if the barbell is being pulled down by a force of 1,200 newtons, it must take 1,200 newtons of force to hold it up. Of course, if we were on the moon, where the force of gravity is only 1/6 that of the Earth, anybody can do it. But we're not on the moon. That looks like hard work. But how much work? 1,200 newtons worth? To lift the barbell? How far? Exactly 2 meters. But what if you only lifted the barbell half that distance, say 1 meter? Surely that doesn't take as much work as lifting the barbell 2 meters. When you lift the barbell all the way up, you're doing 1,200 newtons times 2 meters worth of work. When you lift it only halfway up, you're doing half that amount of work. 1,200 newtons times 1 meter. In fact, this is how you measure work in physics. Work equals force times distance. Here you're doing 1,200 newton meters of work. And here you're doing 2,400 newton meters of work. That's simple enough. But suppose that after the show, the strong man discovers that his car is stuck in the mud. He pushes it and pushes it, but it won't budge a millimeter. And suppose that at the very same time, the clown, who hasn't got a car, is in the act of picking up the telephone to call a cab. Which of them would you say is doing work at this particular moment? The strong man or the clown? The clown. Because work equals force times distance. And although the telephone receiver only weighs about 2 newtons, while the strong man's car weighs perhaps 15,000 newtons, when he lifts the telephone receiver, the clown is applying a force of 2 newtons through a distance of 50 centimeters, let's say, or half a meter. And therefore, he's doing 2 newtons times half a meter of work, which is 1 newton meter of work. The strong man, on the other hand, may be exerting thousands of newtons of force. But since the car is not moving, there's no distance involved, and the poor man isn't doing any work at all. A force of even thousands of newtons times 0 distance equals 0 work, whereas a force of only 2 newtons through a distance of only half a meter does equal some work, even if it's only 1 newton meter work. But it's a bit awkward to keep on talking about newton meters of work. So physicists have borrowed the name of famous British scientist, James Prescott Joule, as the measure of work. 1 joule is the amount of work done when 1 newton of force is applied through a distance of 1 meter. That's to say that 1 newton meter equals 1 joule, which can also be written like this. So the clown did 1 joule of work when he lifted the telephone receiver. And the strong man did 2,400 joules of work when he lifted the barbell. But of course, when he tries to move his car, it's a different story. He does 0 joules of work.
Okay, so work is the transfer of energy that occurs when a force makes an object move. So, as in the cake boss, Anthony was using his body's energy to make the cake move. For work to be done, something has to move, and the motion must be in the same direction as the force. Okay? So the equation for work equals force times distance. Force is always in newtons, and distance is always in meters. Calculating work. Work is in joules equals forces is in newtons times distance, which is meters. For example, if force, hold on, let me get this pen working. You push a wheelbarrow with a force of 100 newtons. So we're going to circle this I'm going to say this is a force. You move the wheelbarrow 5 meters. Meters is a distance. How much work did you do? We're looking for work. Okay. If we know work equals force times distance, the equation is this: work equals force times distance. Okay. Now all we have to do is plug and play. We know 100 newtons is the force. So force goes at the bottom left. The distance is 5 meters. That's the bottom right. You are multiplying them, crisscross applesauce. So 100 times 5 is 500, and that would be Newton meters. But we're going to call it the nickname joules. Okay, so all you got to do is take the force in newtons times the distance in meters, and that's going to equal joules. Okay, I just got to erase all this. This seems to work faster than anything. Okay. Now let's keep going. Power is how quickly work is done. When you're finding power, all you have to do is take the work and divide it by the time it took to do the work. Now remember, work is in joules, so you're finding anything that has joules. That is going to be work. And then time is going to be in seconds. So you're going to take the work divided by the time. The amount of power used depends on how long it takes to do the work. Okay, now there's a little caveat that you've got to understand about power and energy. When you do work on an object, you increase the kinetic or potential energy of the object. Because the energy can never be created nor destroyed, if the object gains energy, then you must lose energy from somewhere else. When you do work on an object, you transfer the energy from the object and your energy decreases. The amount of work done is the amount of energy transferred. So Anthony and his buddy used their body's energy to move the cake. Their energy didn't get lost, it just got transferred into the cake. Okay, we are going to talk about potential and kinetic energy when I get back on Thursday. All right, so let's start playing around with little more real problems here. Find the work done and the power used on the cart if this motion took 20 seconds. So we are looking for work. We are looking for power. We've got 20 seconds. This is time. And you got to look at the picture. 20 newtons. Newtons is always force. 100 meters. Meters is always distance. So let's write down what we've got. We've got a force equals 20 newtons. We've got a distance equals 100 meters. We've got a time that is 20 seconds. It doesn't matter which order you write them in, just so you write it down. The thing that does matter is we need to find work first, because work, you have to have work to find power. Okay, so we know work equals force times distance. So we're going to put this in the T. We're going to put work on top. So at this point, we just have to plug and play because we've got a force and we've got a distance. So we're going to say 20 newtons times 100 meters. And we're going to put that in the T. 20 times 100 is 2,000. And the unit for work is joules. Okay, so that is our work. So we're going to come down here and write 2,000 joules. Now, the next thing we got to do is find power. Power equals work divided by time. For us to put that in the T, you're going to extend out your divisor mark and drop this down and put it in the T. Now you're going to take this number and put it right here. So 2,000 joules. And you want to find time. Time is 20 seconds. So 2,000 divided by 20 is 100. And your units are watts. So power is 100 watts. Okay. Now I'm gonna back everything up again. So we can go to the next couple of pages. All right, I'm gonna skip through a few of these. Skip that because we did that in class. Okay, now here's our worksheet that we're working on. All right, I know it's small, but do the best you can with me here. I can't change the size of it. All right, I need you to recognize that, oops. Let me go back. That I've got a couple of equations here. Your first equation right here is for work. All spelled out for you. This one is for power. Okay. Here is where you write all of your information that you're collecting from the word problem. Now, I want to warn you, in this worksheet, you will use all 6 of these symbols, but in each problem, you are not going to use all 6 of these symbols. Sometimes you're only going to use 5. It's okay if you only use 5. It really depends on whether they give you a mass in kilograms or a force in newtons. Okay, you will use everything else, but the question is, are you going to use mass? All right, so I will show you a problem with force, and I will show you a problem with kilograms or mass. A student's full backpack weighs 10 newtons. Get my pen back. 10 newtons. So we know that's a force because it's in newtons. So I'm going to write 10 newtons. She lifts it from the floor to a shelf that is 1.5 meters tall. So that is distance, 1.5 meters. Remember, distance and height are the same thing. How much work is done on the backpack full of books? So we need to find work. How much power was used? So we need to find power if the action took 5 seconds. So 5 seconds is time. Now, the hard part is over. You figured out all of the units and what they mean. Now, you always have to do work first. So work equals force times distance. We have a force of 10 newtons. And we have a distance of 1.5 meters. So they are right across from each other, crisscross applesauce. You're going to multiply 10 times 1.5 is 15. Your real units are Newton meters, but we're going to call it its nickname of joules. So that is work is 15 joules. Okay. Now we need to find power. Now for power, we have to have work. Work is 15 joules. That goes on top. And the time it takes to do the work is 5 seconds. That goes here. So 15 divided by 5 is 3. And that is watts. So we're going to write 3 watts. Okay. Easy. And you notice you don't have anything there for mass. That's fine. They didn't give you a mass, so you don't have anything in there. Now we are going to look at number 6. Number 6 does use mass. A carpenter lifts a 45 kilogram beam. Kilograms is mass. So we're going to write 45 kilograms right here. 1.2 meters. Meters is a distance. So 1.2 meters. How much work is done? We need this on the beam. How much power was used? If it took 6 seconds. Okay, that was 6 seconds. Now, here's our problem. We've got a kilograms, but we have to have force to get a work. But what you have to remember is you know how to find a force from kilograms. So what you're going to do is you're going to look at your reference table. You're going to find the force equation. There are 2 of them. One of them is mass times velocity, if I remember correctly. And the other one is mass times gravity. We already know gravity. We're going to assume this is on Earth. So we know gravity is 9.8 meters per second. So what we're going to do is you are going to take the mass of 45 and you're going to multiply it by 9.8 meters per second squared, which is acceleration. So that is going to give us a force of 441 newtons. Now you've got a force. This is easy. All we've got to do is take that 441 newtons and put it in the force place. 441 newtons. Okay. And we've got to multiply it by distance. 1.2 meters. 441 times 1.2 equals 529 joules. Now we've got 529 joules here. We're going to take that information and find power. We need to rewrite work, 529 joules. And we are going to take, divided by the time, 6 seconds. So 529.2 divided by 6 equals 88.2 watts. Okay. And that's all you've got to do. I think that will cover all of your questions. So what I want you to do for the rest of the period is I want you to finish your math page. If you don't have a math page, it's in the subs yellow or orange notebook. It's sitting right there on the side. So make sure you pick that up. I want you to finish this worksheet. And then I want you to work on anything that you still owe me, or I want you to finish the notes on the 130s. You should have plenty of work to do. If for some reason you are finished with all of that, You may work on anything else, but I want you to work silently, please. I do not want to hear from this sub that you have given them a hard time. Okay? So I hope you have a good day, and I am going to sign off.